Hans just mentioned the 28 cores in recent IPC architectures. And this is a very good message because we are doing many core control, but some of our customers, they really like single core performance. And for quite some time, the single core clock rate has not increased very significantly. For private matters, you would simply overclock it, which we strictly forbid. Bela, now we have TwinCAT Core Boost. What's that?
Yeah, that's basically the same idea, but fully integrated into TwinCAT.
Okay.
So the user now has the possibility to increase the clock frequency for each core individually. So a very powerful tool. If you imagine you have only one certain part of your application which is very power hungry, it could be the motion application, it could be a vision application, it could also be the machine learning model which is executed on one core. Then you can overclock this specific core to increase the computing performance. And then you can easily execute this bit of your application on this core. And it's fully integrated into TwinCAT, and the most important thing is that we can still guarantee the real-time capability because the overclocking is done permanently.
Okay. That's a very useful feature because I really get that extra amount of power whenever I required it. But why is it possible just now, Fabio?
Yeah. Well, so far, as Bela already mentioned, we were limited to the base frequency.
Yeah.
And the base frequency was so far the only frequency we could guarantee to be permanently available. And this is crucial for the real-time capabilities of TwinCAT, the deterministic behavior. And now with new features we got from our CPU manufacturers, we are able to access the frequencies just out of our application and manipulate them. So initially, those CPU manufacturers used this to save power, but we do the opposite now. We want to use more power, get more power out of the device. And yeah, in this case, it comes just at the perfect point of time, because at the moment we got the development that we get more and more cores. So instead of 4 cores, we have minimum 8 cores.
Yeah.
But we also see that the frequency is decreasing, the base frequency, from 3 to 6, for example, to 2.6 gigahertz. And now for this example, 2.0 gigahertz on 8 cores, we can now accelerate this up to 4.2 gigahertz, so massive leap.
I can imagine that you have to do quite some housekeeping around this, because if you overclock something, if you run faster, it gets hotter, for example. Bela, how do we manage this on the software side?
Yeah, so it's really fully integrated into TwinCAT. So the configuration part is integrated. You can easily decide which core should be overclocked. And on the other hand side, diagnosis possibilities are available, so on the runtime side. So you can see whether the power consumption or how much the power consumption is, the temperature of each core is available, so you can kind of monitor it. And that's what TwinCAT basically is also doing in the background. So if a certain limit is actually reached, so maybe it is the overall power consumption which reaches a limit, then TwinCAT automatically reacts and reduces the frequency for the non-real-time cores. Okay. So we guarantee that the whole system still works and continues to be real-time capable, for example.
Okay. So, but you can also do this with several cores at the same time, right?
At the same time, right.
Limited to one core.
Yeah.
So you can really boost your power. And boosting your power with a software feature is not really good for hardware sales, Fabio, isn't it?
Yeah, well, it's the story of PC-based control, right?
Yeah, that's actually true.
Yeah, so we use, or thankfully we have the software, we have TwinCAT, and we can now have more or make more out of our industrial PCs. And as I mentioned, this is PC-based control, so we got one central PC for more and more tasks. We got MC3 that we are showing here on the booth, machine learning and so on. And this is why we need more performance. Yeah. And on the other side, for those customers who are just growing with us and getting more performance with each PC, they can also decide to now take a smaller CPU, save hardware costs, save maybe costs for the operating system, and as well as license costs, of course.
So we are reducing the costs if required, or we increase the performance of the PC.
Right. Getting more efficient.
Let's have a look at this very impressive overview. At what level of IPCs are we starting exactly, Fabio?
So we want to integrate this on as many PCs as possible.
Yeah.
Right now we are starting with Intel Core i CPUs 11th and 13th generation.
Okay.
And this means we start already with passively cooled C6025.
Yeah.
And then we get up to the big PCs with 13th generation Core i CPUs.
Okay, so it's completely available, and you also told me that it will also be available for form factors of IPCs, which we have for 20 years?
20 years now.
2004, okay.
Exactly, so we got the new PCs, but also the existing PCs, also the big PCs that we manufactured in the 90s already with ATX motherboard. Also, they will be equipped with 11th generation CPUs, and by that get also TwinCAT Core Boost.
Okay, so long-term availability, reliability.
Yeah.
Thank you, Bela. Thank you, Fabi, for sharing
welcome.
this with us.
You're welcome.